Let's see, page 602, we use angle A and angle C. Page 603, we're going to use angle B, and whatever other angle like happens to line up with it. I figured I'd highlight this one from start to finish with you because there's kind of a thought process I want to make sure that I'm outlining. First of all, as I kind of read ahead, I know we're going to use B as the reference angle. And so from angle B, I'm going to highlight the hypotenuse of that triangle. That's using C, so H for hypotenuse, and then K, so opposite side. And then last of all, not important, but I'm still going to highlight it because we need to be addressing it. That's going to put that little line segment right there as our adjacent side. But this is law of sines. We're not really focused on the adjacent sides, only on the opposite and the hypotenuse, because sine is opposite over hypotenuse. In this case, K over C. We always have to look for the right triangle, by the way. So if you have any old triangle, this is relying on your ability to draw an altitude. It might not look like an altitude from that angle, but if you tilt it and then look at it squared on like this, that means that the triangle is now based off tilt of the paper, of course, but this would be the base and this would be the height, and this makes right triangles. Write a ratio that represents sine of C. What you should be practicing this entire time is identifying the reference angle. So I use theta for my reference angle. And then the opposite side of the right triangle that we created with angle C, K is still the opposite side, and B is the hypotenuse. We don't really need the adjacent side, but I'll still highlight it because it feels complete if I do. Sine of angle C is K over B. Do you see what we did on page 602? I mean, if you still have that page next to you, feel free to flip back and look at it. The same argument from page 602 is being made on this page. If we solve for K, multiplying both sides by C, reduce, multiply, K equals C times sine of B, multiplying both sides by B, K equals B times sine of C. Because of that reason, K is the common variable that both of these expressions are equal to. So because both of these expressions are equal to K, that means they have to be equal to each other. So C times sine of B must equal B times sine C. So if we can take that equation and set them equal to each other, because they're both equal to K, and K was that line in the middle of the triangle, that both triangles that are right triangles, they share it. Let's take this C times sine of B equation, and let's divide capital C, and let's divide by BC, little b, little c. So divide the left side by BC and divide the right side by BC. And just like page 602, stuff will cancel. The C's will cancel, the B's will cancel. They reduce to 1 is the better way to think about it. C divided by C is 1. B divided by B is 1. So somewhere embedded in those fractions are 1s, technically, that don't really have to influence things. But that means from the previous page, sine of A, capital A, so angle over A, is equal to sine of C over little c. But that's also equal to what we just discovered here, the sine of capital B over little b. There is our law of sines. And I know I made a YouTube short for you that has this on there, so feel free to scan the room or go watch those YouTube short videos that I posted in your classroom. Thanks for watching, commenting, liking, and subscribing. We're going to put these into practice on the next page, so have a calculator ready, and I'll see you on page 604.